Hello, and welcome back to another video. Today we are going to learn how to apply multinomial naive Bayes to NLP problems. Naive Bayes classifier algorithm is a family of probabilistic algorithms based on applying Bayes' theorem with the naive assumption of conditional independence between every pair of a feature. Bayes' theorem calculates probability, PC vertical bar x, where C is the class of the possible outcomes and x is the given instance which has to be classified, representing some certain features. Naive Bayes are mostly used in natural language processing problems. Naive Bayes predict the tag of a text. They calculate the probability of each tag for a given text and then output the tag with the highest one. Now let's read the data in Python. Let's first read the required data from a CSV file using the pandas library. Now let's write the comment which will allow us to see the dataset. Now, show the data how looks like. Preprocess data. We need to remove the package name as it's not relevant. Then convert text to lowercase for CSV data. So, this is the data preprocess stage. Note, there are many different and more sophisticated ways in which text data can be cleaned that would likely produce better results than what I did here. To be as easy as possible in this tutorial, I also generally think it's best to get baseline predictions with the simplest solution possible before spending time doing unnecessary transformations. Splitting data. First, separate the columns into dependent and independent variables, or features and labels. Then you split those variables into train and test sets. Vectorize text reviews to numbers. Vectorization. To make sense of this data for our machine learning algorithm, we will need to convert each review to a numerical representation that we call vectorization. Model generation. After splitting and vectorize text reviews into numbers, we will generate a random forest model on the training set and perform prediction on test set features. Check the correctness of the model after it has been created by comparing real and anticipated values. This model is 85% accurate. Then check prediction. And there it is. A very simple classifier with 85% pretty decent accuracy out of the box. Thanks for watching. All of the source code is linked below. Check the Substack link. Also, please subscribe to my Substack newsletter. I publish source code for hundreds of projects which you won't find nowhere. These projects will help you get your dream job.